Welcome to Paripurna Academy. I am J. Tabithal and today we are going to discuss topic of thermal expansion and the heat transfer. What is thermal expansion? It is the tendency of a matter which will change its area or volume or even density with a change in the temperature. So, as the temperature changes, these things will be changed by that particular matter. So, temperature is nothing but it is a monotonic function and the average kinetic energy of the substance. And in this session we are going to see what is temperature and what is heat and what are the types of expansions and different modes of heat transferring. Likewise, we are going to see specific heat and thermal conductivity, what is black body and Stefan-Boltzmann law, etc. And finally, we are going to do some problems based on these concepts. Now, let us go into the presentation. First of all, what is heat? So, heat is a form of energy which produces in us the sensation of the hotness or coldness, that is heat. Now, according to the dynamic theory, heat may be regarded as the energy of a molecular motion which is equal to the sum of, that is the sum total of the kinetic energy possessed by the molecules by virtue of their translation, vibrational and rotational motions. So, that the dynamic theory says it depends upon the translation, vibrational and rotational motions. And here comes Joule's mechanical equivalent of heat. So, it is whenever a given amount of work is converted into heat, always the same amount of heat, capital Q, will be produced. So, that we can see W is proportional to Q, or we can say W is equal to Joule, J and the Q, or we can write J is equal to W by Q. Therefore, the proportionality constant J is called Joule's mechanical equivalent of heat. So, it may be defined as the amount of work that must be done to produce a unit quantity of heat. Therefore, Joule J is equal to 4.2 into 10 power 7 erg, that is calorie minus, that is calorie inverse minus 1, which is equal to 4.2 J, that is joules calorie minus 1. So, here comes the temperature. So, it is the degree of hotness of the body. So, the temperature of a body gives the measure of a average kinetic energy of its molecules. This is nothing but the temperature, and it is the device, thermometer is a device which is used to measure the temperature of the body. So, it makes use of some measurable property called thermometric property of a substance which changes linearly with temperature. So, these different types of thermometers are available. So, each thermometer will be used in different fields. So, there is a clinical thermometer where we are, that is in a clinic when we have any sickness, if we went to the hospital, there they are using the clinical thermometer to check our temperature of our body. Likewise, the laboratory thermometer is available. So, that will be used to do research in the laboratories. Likewise, different thermometers are used to find the temperature. Now, here comes the constant volume air thermometer. So, it is used to measure the pressure of a definite mass of air at different temperatures. Then the volume of the air will remain constant. Therefore, it is based on the pressure law P divided by T, which is equal to P naught by T naught, or we can write T equal to T naught into P by P naught. So, in terms of triple point of water, we can write T equal to T TR, that is for triple point. So, TR into P divided by P TR. So, here comes the ideal gas temperature scale. So, the ideal gas temperature on the Kelvin scale is defined by the equation T equal to TTR, that is the limit from 0 to PTR 273.16 into P by PTR, that is the triple point of water, and it is the independent of the nature of the gas, it is depends upon the gas. Now here comes the linear expansion. So linear expansion, when a solid rod of an initial length L is heated through a temperature del T. So it may be different temperature and its final length is given by. So as per the heat is produced, that is when we giving the temperature to that solid rod, the final length of the rod will be L dash is equal to L into 1 plus alpha del T. So where alpha is the coefficient of linear expansion. So it is given by alpha is equal to, we can write it the equation, above equation as alpha is equal to L dash minus L divided by L into del T. So the coefficient of this linear expansion of a material of solid rod is defined as the increase in length per unit length per degree rise in the temperature. So this is about the linear expansion. Here comes the superficial expansion. So when a solid sheet, here it is a solid sheet of the initial surface area S, and it is heated through a temperature del T. So its final surface area is given by S dash is equal to S into 1 plus beta del T. So beta is the coefficient of the superficial expansion here. So it now under above equation can be written with the coefficient of superficial expansion as beta equal to S dash minus S divided by S into del T. So it is defined as the increases in surface area per unit surface area per degree where there is rise in the temperature. Likewise, the another one is the cubical expansion. So when a solid of initial volume V is heated through a temperature del T and its final, that is the increased volume, is given by V dash is equal to V into 1 plus gamma del T. Therefore, gamma is the coefficient of cubical expansion here. So that can be written as gamma is equal to V dash minus V divided by V into del T. So it is defined as the increases in the volume per unit volume per degree which is rises in the temperature. Therefore, the coefficient of the cubical expansion of an ideal gas is equal to the reciprocal of its absolute temperature. Therefore, it can be written as gamma is equal to 1 by T. Now, here we are going to discuss the specific heat. So, what is specific heat here? So, it may be defined as the amount of heat required to raise the temperature of unit mass of a substance through 1 degree. So, if Q, capital Q is the heat which is needed to raise the temperature of mass M of a substance through the temperature, variation of the temperature del T, then the specific heat will be written as C is equal to capital Q divided by M del T. So, the CGS unit of this specific heat is nothing but calorie gram inverse degree Celsius inverse. In the SI unit, it is joule kilogram inverse K inverse, and we can say it clearly, that is heat gained or lost will be Q is equal to MC del T. Therefore, E is equal to M into C into theta, that is the energy, E is the energy and M is the mass and C is the specific heat capacity and theta is the change in temperature, that here we have represented as del T.